Okay, second last subtopic, which is diffraction by a single slit. Okay, just now Young's double slit, sekarang single slit. So you have to explain what is diffraction, explain with the aid of a diagram the diffraction of a single slit, and use these two equations for these followings lah. So diffraction of light is defined as the bending of the light wave as they travel. So bending of light wave lah, as they travel around obstacles or passes through an aperture or a slit comparable to the wavelength of the light lah. So for example, these are some of the slit that these waves are passing through. So this is what we call diffraction lah. It is bend due to this slit. Okay, so this is an apparatus setup, an experiment that is done to see the diffraction of a single slit lah. Okay, so the wavefront from this light source here falls on a narrow slit S lah. So because of that, because this is a slit, diffraction occurs, and every point on this wavefront that falls on S act as a sources of secondary wavelets lah. Okay, so they are superposing each other and then they form an interference pattern lah. So this is the interference pattern. So the central fringe is brighter. The central fringe is bright and maximum, and wider in comparison to the other bright fringes lah. So this is the most bright compared to this and this lah. So the apa lagi ni? So the central bright fringe has the highest intensity, and the intensity of the bright fringe, as it goes further away from the central bright, it decreases lah. And then what else? Yeah, that is basically that. Other rays with angle delta 1, delta 2 will produce minimum and maximum on both sides of this central maximum lah. So there's going to be positive and negative macam tu lah. Okay, so let's look at the equation for separation between central maximum and minimum dark fringe. So maximum and minimum. Coba. Okay, sorry, let me just check. Okay, betul lah. So this is the equation for you to determine between the distance of end minimum from central maximum. Okay, so kenapa this one end minimum? Okay, betul lah. So distance of end minimum from central maximum. So this is the equation, this one lah. So A is the didn't I write what is A? A is the slit width lah. So A here, so that is the width of the slit. Okay, yeah, all right. Now what else? So that is the equation. Yeah, itu saja. Let me just double check. First, second, third. Yes, first, second, third, minimum. Okay, now let's look at central maximum, which is bright, and maximum fringes juga. So bright and bright. So that one, the maxima, which is bright fringe, is given here. So if you simplify that, you will get this equation. Again, the small letter A is the width of the slit lah. You just have to apply this equation in a problem, in a situation lah. Okay, yeah, itu je. So you just have to use. So this pula is the equation for central maximum lah, which is the bright fringe, which is the one shown here. So these 5 dots here are basically the 5 sources of the Huygens wavelets, and the screen is to be so far from the slit lah, so that the rays from each source are nearly parallel. So the angular width of this central maximum, angular width of the central maximum is given here lah. That is the the angular width of the central maximum. Maximum, because this is, aduh, kenapa dah boleh ni? Bright fringe, okay? Because it is bright fringe. So, this one pula, that is telling us about the diffraction angle lah. So, if you, ini yang short punya, actually I'm just gonna use. So, this is the equation lah. Okay? The width of the central maximum pula, the width of the central maximum, this one is the angular width, and then this is the width of the central maximum, which is this one shown here lah. Okay, so y1 pula is the separation of the first minimum, separation of the first minimum and central maximum. Okay, please remember what each of these are telling us. Like contohnya this one, lambda is wavelength lah, we know that. A is the width of the slit, and then 2y1 is what? You need to know what is y1 because you have to find it lah, you have to calculate it. So y1 is the separation of first minimum and central maximum. Okay, and then if a question asks you to calculate the maximum number of orders, observe we have to take the angle theta to be equal to 90 degree. Okay, and then from the both of the equations for minima and maxima, we've obtained this. So by using this two relationship, the changes of single slit diffraction pattern can then be explained lah. So just guna this relationship. Alright, I'm getting tired. So that is our fifth subtopic.